You're going to need a calculator. You need to write down this formula to get your temperature for Kelvin. Okay, no one should be talking while I'm instructing. Okay, to get Kelvin, whatever your Celsius is, you're going to add 273. That's going to be your conversion, okay? So here, I can already see two that are going to need to be converted, right? That 36 Celsius. You're going to add the 273. Go ahead and do that now. How much is my Kelvin for T1? 36 plus 273. How much is that?
309 Kelvin.
Guys, let your fingers do the walking. 273 plus 36. How much is that? 309 Kelvin. Very good. Okay, so that's going to be your T1. Okay? Now, your second temperature, your T2, is 94 degrees Celsius. So still plus 273. So you can get the Kelvin. Bless you. How much is 273 plus 94?
I got this 367.
73. Okay. 367. Okay, maybe it's the other one. Hold on. 36 plus 273. Something looked off there. All right. So now, your formula for Charles' law is V1 T2 equals V2 times T1. Okay? So my first volume is 473. Remember, centimeters cubed is the same thing as milliliters. Remember that also liters is your volume as well. Okay, so remember your objective here is to match that unit with the variable it's supposed to go with and figure out what is missing. And so you're going to solve for x. Okay, so my V1 is 473 centimeters cubed. My T2, make sure you're getting the second temperature. That's the 367 K equals. Then my V2 is what I'm missing. And now I need my T1, which is what? 309. Very good. So now, this is just like the problems that we did with molarity, right? The molarity by dilution. You're solving for x. I want that V2 by itself. So my answer is going to be in milliliters, or sorry, centimeters cubed. Let's go ahead and erase that. So now, we're going to divide by the 309 Kelvin, because that's going to cancel out. What you do to one side, you must what? Very good. You must do to the other side. So this is going to allow you to cancel the temperature out. All that's going to be left is the volume. So 473 times your 367 equals, you're going to divide by 309. 561 and what? 0.8. Okay, so this is your volume. Okay, right there. What questions do we have so far? Are we sure? Yes.
What does the 273 come from?
That's your conversion for Kelvin. This is your conversion right here. You might want to write that down. So whatever your Celsius is, plus the 273. Even, can I have a negative number for that? Could I have like a negative 27 Celsius?
Yes.
Yes, you can. And then plus 273, that'll give you your Kelvin. Yes.
So the 473 is the volume.
The what?
The 470 in the problem, the 473 is the volume, correct?
No, you're not dividing by 473.
No, I mean like not for the, but is it like for the, is it the V1?
It's your volume 1, yes. Uh-huh. Let's go ahead and go. The worksheet, by the way, is in your Google Classroom. Because I was out sick yesterday, I didn't get to make copies, so it's in the Google Classroom. And I'll leave it on the projector just in case, all right? So here's your number 1 for today's worksheet. This first one is Dalton's Law. What?
Are we doing this in our drill?
This is going to be on a blank sheet of paper. Okay? Here's my first tour. And here's my second tour. Guys, let me show you how to do it. Okay? That way you don't miss out on what you're supposed to be doing. Okay? This is your first pressure. This is your second pressure. Okay? They're asking for what is your total pressure. So now remember on the formula that I just gave you, your total pressure is your P1 plus P2 plus P3, etc. Okay? So what do I need to do here to get my total pressure? Yep, that's it. That's all you have to do. You're going to take the 736 plus the 22 torr. Do not forget the units, okay? And that's going to equal your total pressure, okay? What if I had, look at number 2. They're giving you the total pressure. So you're going to take away the P1 and your pressure 2. That way you can find your pressure 3, okay? Now, guys, don't forget to still show your work. Okay, now let's look at number 3. Here you have temperature 2, you have temperature 1, and then you have volume 1. So what formula are we going to use here? The Charles law. So V1, T2, yes, okay. All right, so what do I first have to do here before I do the problem? Yep, you're going to convert 20 into Kelvin, and so, that one as well. So the 20 plus 273 is how much?
293.
Yep, 293, and so this is my T1. And now the 60 plus the 273 is going to give me what? 333 K. Very good. Okay, so now let's go ahead and do the problem. V1 is 600 milliliters. T2 333 K. Very good. And we're looking for V2. Now, guys, I know our last example was also looking for V2. It's not always looking for V2. That's just a coincidence, okay? You could look for T1 or T2 or for V1. It has to be one of them, all right? And my T1 is what? 293K. Okay. All right, very good. What's going to be my next step here?
Divide it. You do one side, you do the other.
But I'm dividing by what?
293.
Very good. The 293K. And I'm dividing by the 293K. So this cancels out on this side. That means that's going to leave you your volume in milliliters because that's the unit you have left, right? So 600 times the 333 equals, then you're going to divide by the 293. How much does that give you?
681.91.
So let's do 1 sig fig after the decimal. Okay, so then that is your volume. We see that there? What questions do we have so far? My voice is gone. We good?
This will be on YouTube, right? That's pretty easy.
Huh?
This will be on YouTube.
I'm going to put this on my channel, yes. Okay? Any questions on the units or on the formula? No? Or on the partial pressure?
So partial pressure, you're just adding up all of them.
Mm-hmm.
Find the-
Yes.
But if you have the total pressure, you just subtract.
Right. If they give you the total pressure, let's say it's 400, and then they give you a partial pressure of 150, a partial pressure of, let's say, 50, and another partial pressure of, let's say, 50, and let's say these are all in torr, and let's say this is on torr, and they want to know what your partial pressure is for the fourth partial pressure. Well, 150 plus 50, 200, plus another 50, 250. So what's going to be my fourth partial pressure if my total partial pressure is 400? 400 minus the 250.
150.
Whoops. Sorry. Oh my gosh. Seriously, I really must be sick. Okay. The 400 minus the 250. And there's your 150 torr. This will be your fourth partial pressure. Okay, you see that? Yes? Okay, so we're all good? Okay, make sure that you show all the work. You don't have to write the problem. And it's in the Google Classroom, but I'll leave it up here just in case you guys want to see it, okay? It's due today. Once you're done with it, you're going to show it to me so I can stamp it. Once you have the stamp, make sure you write your name in pen and then load it up to Google Class, okay?